Today we are learning functions. What is a function? A function is a rule that assigns each input exactly one output. For an example, if we draw a line, and this line is y equals to 2x plus 3, where we have x-axis as the domain, y-axis as the range. This is a function because for every x value, it will correspond to exactly one y value. This is a special case of function, and this is known as a one-to-one function. Domain is a term that we use here to represent all the x values on the Cartesian coordinate system. Range is another term that we use to represent all of the y value that we have on the y-axis. In another example, if we are trying to draw y equals to 2x, in this particular case, the domain is everything in the x-axis. So we say the domain is all real numbers. The range is also everything available on the y-axis. So we say range is also all real numbers. A one-to-one function, as I said earlier, is a special case of a function where every output has only one corresponding input. For an example, y equals to x to the power of 3 is a one-to-one function. If we look at how it will be if you look at how it is drawn, for every x value, you only have one y value corresponded. But y equals to x to the power of 2 is not a one-to-one function, because at x equals to 2, at x equals to negative 2, it can both correspond to the same value of y equals to 4. So we do not call this one-to-one function, but we call this one-to-one function. Inverse function is denoted as this, where you have f and then superscript -1. It means it reverses the operation of the function. For an example, if fx equals to e to the power of x, which is an exponential function, and its inverse will be ln x. The domain of the function is equivalent to the range of the inverse. The range of the function is equivalent to the domain of the inverse. So these two are equivalent, and these two are equivalent. Composite functions. Composite function is a combination of two functions. The notation f composite gx represents f encompasses, includes gx. If fx is 2x, gx is x plus 3, f composite gx is going to be 2, and you're going to replace x by x plus 3, and that's the reason why we will get 2x plus 6. Here are a couple of function notations. For example, this is how you write functions. This is how you write inverse function. This is one of the other way you can write composite functions if you are compositing the same function by itself, like f composites fx. You can also write it as f superscript x. Trigonometry functions is another type of functions that you should be aware of. Certain functions do not have an inverse, and that is because they are not one-to-one. If you would like to have an inverse function, you must be a one-to-one functions. If it doesn't have, if it is not a one-to-one function, then it is not having any inverse function. So for inverse functions, is actually having a reflection in this particular line of y equals to x. The example that we gave earlier, y equals to e to the power of x, may look like this. And if you look at its inverse, which is y equals to ln x, and you will look something like that, here you can see both of these are actually reflections of each other in the line of y equals to x. So that is the graphical meaning of inverse functions. It is a mirror image on y equals to x. Summary. So you have to understand, in this particular video, you understand what is functions, what is the meaning of domain, range, what is one-to-one functions, and what is inverse functions. You also learn some function notation, composite functions, and also in the additional reading materials, you will be able to see more of the examples to solidify your understanding about this. Thank you very much.